Welcome to this explainer. Today, we're going on a wild journey to the absolute edges of modern computing. To solve humanity's most tangled problems, researchers Hai, Chun, and Kai asked one radical, beautiful question. It's combinatorial optimization, basically finding the absolute perfect needle in an infinitely expanding haystack. Normal computers hit a literal wall here. They just choke on their rigid zeros and ones. These problems look like incredibly massive, overwhelmingly complex webs. Take the notoriously tangled Mobius ladder. Whether we're matching molecules for drugs or analyzing global credit, the sheer number of possibilities is staggering. The team knew building a computer powered by light would be agonizingly tough. Light is so fragile. They hit agonizing dead ends. A microscopic temperature shift or tiny vibration ruined entire calculations. The light kept getting stuck in wrong answers, a totally frustrating roadblock. We'll be right back. Okay, we're back. So, the breakthrough? They ditched standard light for something unimaginably fast. Femtosecond lasers. We are talking pulses lasting less than 300 quadrillionths of a second. These microscopic pulses delivered massive peak power, triggering profound, wild quantum effects within their setup. To tame that raw power, they literally built a custom acoustic and temperature incubator. The culmination of this agonizing journey? The most advanced coherent Ising machine in the world. The result was a staggering 55% success rate on that insanely complex Mobius ladder. This ultra-fast method didn't just casually beat previous computing records. It absolutely obliterated them. These patterns prove it. Those lightning-fast pulses forged incredibly stable, clearly defined quantum states. And even better, they achieved an absolute marathon of stability, 8 continuous hours of flawless computing. Over 18,000 complex calculations executed flawlessly, without a single drop in performance. Just amazing. Plus, this isn't just a lab experiment anymore. It's literally running on the cloud right now. It's ready to tackle our biggest challenges, from designing life-saving medicines to hyper-complex financial modeling. So if light solves our most impossible problems today, what exactly will it illuminate tomorrow?